I recently recorded a video about some analysis I'd done on prudence levels in the 2020 valuation, the USS valuation, that is. And I said that I would possibly record another video trying to explain why the effect that I noticed there holds. Let me just remind you of what the findings from my analysis were. So the first was that the prudence levels that USS had stated in their document that went to employers, their technical provisions document that went for consultation with employers, only makes sense relative to gilts. There's a table here which I showed, which has the confidence levels for any given choice of discount rate. And if you remember, there was lots of bases that this was discussed under pre and post-retirement in a strong and tending to strong case. But anyway, there were these confidence levels here. And as I say, they only make sense relative to the return on gilts, or another way to say that is with reference to the gilts plus distribution. And even though in the same document USS state returns relative to CPI, in particular I focused on this figure here of CPI plus 0 for a tending to strong covenant, and say that they're equivalent to a gilt rate which is achieved by or derived from the confidence levels shown earlier, it's not the case, at least according to my analysis, that this rate relative to CPI is at the same confidence level. But I did state that I didn't think there was any error in any of the numbers that were presented. There could be, but I don't know of any, and I don't believe there is likely to be any. But something more subtle is going on. If you remember, I claimed that the CPI plus 0% in the tending to strong case could correspond to a prudence level as high as the 90th centile, 90% confidence level, and that in the strong case, this CPI plus 0.5% may be as high as the 85% confidence level, which is significantly higher than the one stated earlier on the previous slide. So let me explain how I think this might be possible, or give one explanation for why this is possible, and then maybe muse about a couple of other potential causes. How is this possible? Now, the best way I can think of to show what might be happening is with what I'm calling a toy example. And these confidence levels that I was showing on previous slides and discussing all come from what's called a stochastic model that USS run. So that's a simulation of the future where you feed in certain assumptions and let the computer randomly generate, I think in USS's case, it's 2,000 runs of the future where each of your parameters, each of your variables is allowed to vary year by year. And then you look at the outcome at the end of 30 years of those 2,000 different simulations to achieve a distribution of returns, which is, so that allows you to talk about which percentile various figures are achieved at. But their model isn't available for scrutiny, so we can't look directly at it and figure out what's going on. Instead, I'm going to construct a really simple, what I'm calling a toy model. So in our stochastic model, what we're going to do is assume that CPI is 0% every year, and there's no variation in that. So suppose we know that by some government policy, they manage to keep CPI at 0%. Okay. Suppose also gilts are expected to lose us 1% per annum, but that's the, if you like, the median guess, the central expectation, but that there's going to be some variation in what gilts return, but the variation occurs according to a normal distribution with a 1% standard deviation, plus or minus 1% standard deviation around that central expectation. Now, let's consider an asset class of cash in a vault. In other words, what happens if we put hard cash into a vault, which will return 0% per annum. It won't grow. It will be the same when we take it out of the vault in 30 years' time as before. And of course, there is no variation in the returns we will achieve. We know from year to year precisely how much cash is in our vault. Now, the first point to observe is that cash in a vault returns CPI plus 0% in every simulation in our model. Okay, well, I mean, that's obvious. CPI is 0 and our returns on our cash are 0. So at the end of 30 years, neither CPI nor our cash will have changed. They're the same. So the CPI rate was 0, sorry, and the cash won't have changed. Okay, so if we measure the returns on our cash in a vault relative to CPI, we find that we've achieved CPI plus 0% annually on our returns in every simulation. And that means every centile of the distribution is CPI plus 0%. But if we look relative to gilts, then at the 50th centile, the central expectation, we will find that our gilts will have lost 1% per year. So relative to gilts, cash in a vault will have grown by 1% per year relative to gilts. It hasn't grown, but it's the gilts that have fallen. But relative to gilts, we've achieved 1% more than what we achieved by the gilt rate. That's at the 50th centile, because that's our central expectation. But remember, our gilts distribution was a normal distribution with standard deviation of 1%. And that means that, in fact, at the 85th centile, or possibly the 15th centile, we had this issue in the previous video, depending on which way round you view your distribution, our cash in a vault will achieve gilts plus 0%. Why is that? Well, because around 15% of the time, the gilts will have outperformed their central expectation by one standard deviation. And in that case, the returns on gilts will be 1% higher than they otherwise would have been. In other words, they'll have hit CPI. In other words, they'll have matched the returns for our cash in a vault. Okay. Now, suppose for our valuation, we decide that the returns that we are going to choose on each asset class are at the 85th centile of the distribution relative to gilts. Now, this is the kind of thing USS have done. They've said this portfolio will outperform gilts by a certain amount at the stated centile. So let's take the 85th centile here for ease of example. Now, what does that mean? Well, it means that for cash in a vault, in our valuation, we are saying it will return gilts plus 0% at the 85th centile. Remember, at the 50th centile, we assumed that we found that cash in a vault would return gilts plus 1%, but at the 85th centile, it will return a lower amount, namely gilts plus 0%. Now, one key part to this is precisely what we then do with that figure, but suppose we then feed that into the valuation by adding 0% to our central expectation for gilts. Well, in that situation, what we'll find is that cash in a vault is, in our valuation, assumed to return CPI minus 1%, 1% lower than CPI. But of course, CPI minus 1% is nothing like the 85th centile of the distribution for cash in a vault relative to CPI, relative to inflation, because as in point 4 above, we found that cash in a vault would return 0% above CPI at every centile. We know it will always match CPI in every simulation, so it's certain, according to our model, to return CPI plus 0%. Okay, so the conclusion is that by working relative to gilts rather than CPI, we've added some extreme prudence into our valuation here. In our situation, it's off the scale, because we're assuming that cash in a vault in our valuation will lose 1% of its absolute value each year, which is nonsense. At the end of 30 years, we'll find a compounding effect, and we've got significantly less cash in our vault than what we put in, which is self-evidently nonsense. Right, so I think that an effect like this could be part of the explanation of what was going on in my previous talk. I'm not certain of it, because it all depends on this step 7, how we interpret the return of gilts plus 0% for cash in a vault. Does it correspond to CPI minus 1% in the valuation? If it does, the rest follows. And I don't know whether this is precisely what USS is doing, because again, they don't make that amount of detail clear. So we can't check. So this is speculation, but it's the best explanation I could come up with for the effect. Now, of course, I've created a simplified and quite extreme example here, but I think the same kind of effect, but to a lesser degree, will happen any time your standard deviation of your returns relative to gilts is greater than the standard deviation of your returns relative to CPI. And of course, that's what I observed in the previous video as being the case according to USS's numbers. The variance or standard deviation of their distributions relative to CPI are lower than the variance or standard deviation of the distribution relative to gilts. So I think that's part of the explanation for the effect that I observed. There could be other explanations. There is an assumption of gilts reverting over the first 10 years of the time period in question to previous levels that USS is using. That could have an effect as well. And there could be other explanations I haven't yet thought of. Of course, it's up to USS to tell us the explanation of this because they're the only ones with access to the full methodology and full models. But anyway, I hope that video was useful. There may be slight errors in my reasoning here. Well, I don't want to say errors in the reasoning. I'm not a statistician, and I could have used slightly the wrong centiles for deriving various things, but subject to tweaks, this I'm sure all holds together. Right, okay, I will stop there. And if anybody does have ideas about what's going on that either confirm these ones or suggest other ones, please do let me know.